Welcome, excuse me. Welcome back to the video series for Geography 300, WVU. We have, in the past several videos, been looking at different ways of understanding our data. We're continuing this, now moving from the different types of data, whether you're looking at that as whether your data is primary versus secondary, whether it is explicitly versus implicitly spatial, or things like that, or the different attribute types, the nominal, ordinal, interval, and ratio scales. We now look at, in a sense, ways that our data can pose problems and be wrong and be sources of uncertainty. This is, in some ways, a key lesson for statistics, because statistics is very, very rarely truly black and white. We deal with probabilities, we deal with shades of gray. How likely is it that our hypothesis is true? How likely is it that the data supports the hypothesis? And I use that phrasing very precisely because of these sources of uncertainty. That the data, the data themselves may have problems. And if they do, that uncertainty can mean there's a problem with the data. Even if our hypothesis is true, the data may not support it. Or likewise, it may appear that the data supports the hypothesis because it has uncertainty or it has problems, but that hypothesis is actually kind of false. So we'll look at these different sources of uncertainties, different ways that, in a sense, our data can have problems and go wrong. The first of these, is precision. Precision is, as the name suggests, how precise is your measurement. So if you think about, say, different ways people might measure the length of something. Now, if you don't have any tools on hand, you might estimate that your foot is about the length of a foot, 12 inches. And just step out. 1, 2, 3, 4 feet, literal feet, and come up with an estimate. It could also be, if you know your pace is about 2 meters, or 1 meter, or however long it is for you, to say, okay, I am going to just pace out, recognizing that each left foot to right foot is about a meter. And you can come up with a very rough estimate of that length. You can then have a measurement. It may well be accurate in the sense of it's as good as you can get with that approach to measurement, but it's not very precise. So we say, you notice a length of something is about 300 meters. Versus if you go and you have proper surveying equipment with things like maybe a terrestrial LiDAR, and you can get a very, very precise measurement of that distance, and it comes out to 301.963 meters. Those are actually pretty close to each other, so it's not that this was, as far as it goes, wrong. It's just that it doesn't measure it down to the millimeter. if you think back, say, to high school science courses, where you probably talked about significant digits at some point. The idea of significant digits is itself based on this idea of precision. The more significant digits you have, the more precise your measurement is. Precision is often confused with accuracy, but it should not be. A measurement can be very precise, but wrong. So every so often, you can see on a phone's GPS, for example, a case where it just has the location wrong. It's telling you very precisely where it thinks you are. It is giving you a location down to probably about a meter, or maybe 10 meters off. It's giving you a very precise measurement with a lot of significant digits in terms of where on the Earth's surface you can be found. The only problem is if it's not accurate and it decides for some reason to put you in Pittsburgh instead of Morgantown. That would be a measurement that is not accurate. Likewise, with this distance idea, if the terrestrial LiDAR system was not calibrated correctly, or had some kind of interference, like maybe even something like a bird flew across the path, its measurement can be very precise but not accurate. These two, based upon two different sources of uncertainty, precision and accuracy, as I said, they're often confused with each other. They're the ones most directly related to exactly how the data is collected and measured. The next one is currency. Is the data current or new or recent enough to still be accurate in a sense? If you are, so for example, to take a very egregious example, if you wanted to look at demographics for Morgantown or for Monongalia County, you pulled census data from 1960, the population would be much smaller. The university was much smaller in 1960 versus today. And that means the population is less, and there probably would have been a different ratio of people living in the town, who are kind of the townies, the older, more permanent residents, versus the student population. So things like the total population, the average income, because the students are counted as residents of the county, but tend not to have a large income, so that pulls the average income down. It pulls the average age down. Those would all be problems because the data, the attribute, is out of date. That doesn't mean it was inaccurate at the time it was collected, but it has since, through the passage of time, become out of date and no longer current. That is the idea of currency. The next type of uncertainty or source of uncertainty is whether or not the data is reliable. So if the data and the data collection method is reliable, then you can repeat that and get the same measurement. So I can bring up my phone and say, okay, tell me where I am. Close Google Maps, bring it up again, ask it again for my location. It's going to give me pretty much the same measurement. It might be shifted a few feet, but it's going to be pretty much the same thing. That means that measurement is reliable, that data is reliable. The cases where you're most likely to encounter data that would not be considered reliable is with, especially with nominal data, where the differences are subjective. This could even fit for some of the ordinal data too. I'll give a couple examples. If you are having people go and identify the land cover type of a plot of land. Now that plot of land does have some trees on it, but it also is not a complete canopy, and there is grass in between the trees. One person may decide, okay, there's grass, it's not a complete canopy, I'll call it grassland. Somebody else may say, no, there's plenty of trees here, even if it's not a full canopy, I'm going to call it forest. It is the same plot of land, you're asking, in a sense, the same kind of measurement, having somebody go and assess what the land cover type is, but they disagree because it's not an obvious delineation of here is forest, here is grass. So in that context, the data may not be fully reliable. The other example, using ordinal data, I'll go back to the SEI scores. One person may think an instructor or the class was excellent. Somebody else may just think it was fair. Somebody else may think it was absolutely terrible and give it the absolute lowest rating, while other people gave it the absolute highest rating. There is rarely 100% complete consensus on the rating for a course. So that reduces, in a way, the reliability of using SEIs to measure an instructor's effectiveness. We still do that because they're better than nothing, but the fact that different students can disagree does mean it is not a 100% reliable measure in the sense of repeated measurements. One person, another person sitting in the same room at the same time have the same exact measurement of the assessment for that class. The last source of uncertainty, which is probably the most complicated one or the trickiest to wrap your head around, is the idea of validity. So if the data is valid, then you can say it measures what you are actually wanting it to measure. This can come up more than anything else in different indices that are based upon multiple attributes. So we might say something like, okay, I want to measure the socioeconomic status of a community and come up with a measure of well-to-do to impoverished and have a scale between those two. To accomplish that, I have to choose attributes that are available in my data set to have that index that is intended to measure socioeconomic status. I can then put in things like, um, if we wanted a valid measurement, we'd probably put in things like the per capita income or median household income, the percent of the residents of that county who live under the poverty line, the percent of people who are recipients of Medicaid, the percent unemployed, and have different ways to measure the extent to which a community is well-to-do or not well-to-do. However, we might initially think of taking a few variables, things like the percent of properties, rental properties that are vacant for much of the year. And you could say, okay, that's a measure of distress. A lot of the properties are vacant, there's not much going on in that community. We might look at the percent of people who do not have jobs. That, on the face of it, would seem to be a good measure similar to unemployment. We might look at, say, the number of people who live on a fixed income, where, okay, that could indicate a lot of people on unemployment insurance, unemployment assistance, or other welfare state type benefits to ensure a minimum income. However, there are many places in Florida that would be counter to that, that would make that collection of variables a very invalid measurement of socioeconomic status. Because the percent of rental properties that are vacant could also refer to rental properties or to people's summer homes or winter homes if they're in Florida. So people who have a second home, it would be vacant much of the year. That doesn't mean they're poor, they have two homes. The percent of people who do not have a job. A wealthy retiree who spends half their time up north and half their time in Florida, they don't have a job, they're retired. So again, that's not a valid measurement. And fixed income, again, this idea of they're retired, they're collecting Social Security. They do have that fixed income. Again, that's not a guarantee that they are poor. So, something based, to recap, something based upon things like the percent of households living in poverty, the unemployment rate, which is based upon the number of people who are actively seeking to find a job, and things like the median income, those would be valid measures of socioeconomic status. Whereas the percent of properties that are vacant much of the year, the percent of people without any job, the percent of people living on fixed income, that would not be a valid measurement of socioeconomic status because, as I said, there are plenty of retirement communities that are counterexamples to that. When we are evaluating our data, we want to make sure all 5 of these categories are as minimized as sources of uncertainty as possible. So our data is as precise as it can be, as accurate as it can be, as current or up to date as possible, as well as reliable and valid in measuring what we actually want it to tell us. So all of these as sources of uncertainty can affect our analysis, can affect our conclusions, even though we do strive to minimize them as much as possible. So, as always, if there are any questions, please email, please reach out during the in-class Q&A sessions, and I will see you at the next video.